in symbolic logic, basically what we do is we, instead of writing out whole sentences and stuff, we use letters and symbols to look at the truth values and various other things. So we also will look at what are called compound statements. It's created by combining two or more statements. By the way, a conditional statement is a compound statement. It has a hypothesis and a conclusion. You've combined two other statements. So we've already done that one, but the two other ones that we'll deal with are a conjunction and a disjunction. A conjunction is a compound statement using the word and. It's true only when all of its parts are true. So you can write it P and Q, or symbolically, and this is what we're going to do, this is P and Q. And I think it's pretty easy because it kind of looks like a capital A without the little crossbar. Okay? A disjunction is a compound statement using the word or. So this isn't quite the same as it is in English, where a conjunction is, pretty much any of those linking words, and, or, but, etc. In math, or is a disjunction. It's true if any of its parts is true. So in words P or Q, symbolically P, and this looks like the upside down of the conjunction. So it's or instead of and. So let's look at some truth values based on these three simple statements. First one, Austin is the capital of Texas. We probably ought to make sure everyone knows whether these are true or false. Austin is the capital of Texas, true or false? True. Pecans grow on trees, true or false?
True.
That's also true. Animals with wings can fly?
True.
False. Ostriches, penguins, kiwis, emus. There are several flightless birds. They've got wings, they just can't fly. So we're going to look at the truth value of each of these. So Q disjunction R, or Q or R. How many of those have to be true for this to be true? Just one of them. And Q is true, I don't even have to look at the other one. This is automatically true. P conjunction R, P and R, how many of these have to be true? They both have to be true. Are both P and R true? No, so this is false. This is the one, we've talked about it already, but this is the one that bothers students the most. R implies Q.
True.
Why is this true?
If there's an incorrect first statement and a correct second statement, that's true.
Okay, let's see if we can use the terms. You're exactly right.
I forgot.
Okay, if there is a false hypothesis,
And a true conclusion.
then it's still true. In fact, if there's a false hypothesis, it doesn't matter what the conclusion is. Again, think about what this is saying. This is saying that if animals with wings can fly, well, that doesn't ever happen, then Austin is the capital of Texas. Okay, well, since this never, ever, ever happens, you can't prove that it's a lie. The one that I use, again, I think I used this last week with you guys, is that if I tell you, if I win the lottery, I'll give you each $1,000. The only way you can prove I'm a liar is when I win the lottery and I don't give you the money. Other than that, you can't prove that I've lied. Yes, sir.
So if you win the lottery, will we get $1,000?
Sure.
Really?
Yeah.
Oh.
The fact that I don't play the lottery makes that really difficult.
Maybe
Mathematician,
Do a lot.
yeah, mathematicians don't play the lottery
Why?
because they know the odds.
Everyone knows the odds. It's like 293 million.
So basically, you're standing in line and paying money. You're willingly paying taxes. Okay,
A lot of people fall to gambler's fallacy.
pardon? Which is what?
So thinking you have a higher chance if you buy more, while you do technically have a higher chance, it doesn't increase 1%, which it doesn't increase the amount of percent every one you buy.
Right. Also, if I buy two, I've doubled my chances.
No.
Which is no, I have doubled my chances.
Yeah.
That part's true, but are they any good yet?
No.
No.
You need to spend a lot more reward to get a good chance.
Yeah.
Buy, like 2 million, you have a 1% chance about.
Well, and so the way that gambling hooks people is with things like scratch cards, where you win $2, right? If you win $2, you're ahead $1. Does anyone quit at that point? No. They almost all go, I won $2, give me 2 more tickets. And they play until they lose. And I'm like, okay. But that's part of how you get people hooked on something is you give them a little taste of victory, right? And then over time, they're like, well, but I've won so many times. Yeah, you've lost way more than you've won. But people tend to not keep track of those. That and there's an endorphin release when you win and all that kind of stuff. So physiologically, endorphins are the things that make you feel good. Anyway, moving on. So this symbol right here is the negation. You can think of it as a not or the opposite of. So this says not P, disjunction Q. So since P is true, not P is false. So that's false. I can still look because I only need one of them to be true. Q is true, so this is true. All right, how about this one? Not Q. So that's going to be false. Implies I don't even have to keep reading. If the hypothesis is false, this is automatically true. If the hypothesis is true, you have to look to see if the conclusion is also true. And then this one, not R, that would be true. And Q, that's also true. So this is true. So we'll do some questions like this, but the other thing we'll do is something called a truth table. So a truth table lists all possible combinations of truth values for a compound statement. We're going to construct a truth table first for P implies Q, P and Q, and P or Q. So what we're going to do is we're going to do this by columns. We're going to have a column for P and a column for Q. Now, each one of those has two possibilities. It could be true or it could be false, right? So since there's two of them and there are two possibilities, if we take 2 squared, there are 4 total different possibilities. There are 4 different combinations of true and false for P and Q. So it could be that P is true and Q is true. P is true and Q is false. P is false, but Q is true. And P is false and Q is false. And that's usually the order that I do them in. You do not have to do them in that order. I will say it makes it easier for me to grade, but that's not a big deal. If you don't do them in that order, it's not a problem. All right. So I want to look at P implies Q. When will P implies Q be true? All right, when P is false, or
If P is true and Q is false. I mean, true and true.
right, if P is true and Q is true, this is true, or anytime that P is false. So this is going to be true, this is going to be true, this is going to be true. The only time that it's false is I won the lottery, but I didn't give you the money. So this is false. Let's look at P conjunction Q. When is that true?
When both are true.
When both P and Q are true. So the only one that's true there is this one. The rest are false. And now let's look at P disjunction Q. What has to be true for this to be true? Just one of them has to be true. So that's true, 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 false. All right, let's do a more complicated truth table. We're going to construct a truth table for not P and parentheses Q or R. So this time I have 3 different things, and each one has 2 possibilities. So I've got 2 to the third is 8 different possible combinations. Because you've got P, Q, and R. I think the simplest way to start this, so that you get all the combinations, is do half true, half false. Oops. So I'm going to do true, 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 and then 4 falses. And then do half that many. So now 2 trues, 2 falses, over and over. And then 1 true, 1 false. If you do that, you'll always get all the combinations. All right, the first thing in my compound statement is not P. So I need a column for not P. You don't start with not P. Every year I have at least one student who decides to do that. And I'm like, well, I need to know what P's truth value is before we get into this part. So for not P, well, that's just the opposite of P. So that's false, 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 true, 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 true. And I want to put that together with Q or R. So I need a column for Q or R. So for Q or R, what has to be true?
Q or R.
Either Q or R. So that's going to be true, 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 false, and then that pattern's going to repeat. True, 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 false. And now I'm going to put those two parts together. Not P, conjunction or and, Q disjunction R. So my two parts are the not P and the Q or R. Oh, sorry, I put an and in both places. Thank you. So in order for this to be true, what has to be true about not P and about Q or R? They both have to be true. God bless you. So that's not true here. I've got a false and a true. That's not true. False and a true. That's not true. False and a false. That's not true. Oh, then I find some that are true. Here, both of those are true for the next three. And then I've got a true and a false. All right, one more. I'm going to change this one just a little bit. Let's not use V for this last one because then that looks like, an or. Let's change this to an X. That'll be pretty easy. So how many columns am I going to have this time? I've got three variables, U, V, and X, or three statements. So that's going to be two choices to the third. I'm going to have 8 again. So I need a column for the originals, U, W, and X. So just like I did on the last one, I'll do 4 trues and 4 falses. And then I'll do half of those, so I'll do 2 trues, 2 falses, and repeat. And then I'll just go true, false, true, false, true, false. Sir?
What would happen if there was a fourth line? What would the pattern be?
A fourth line. Oh, there'd be 16, and I would go 8 trues, 8 falses, 4 trues, 4 falses, 2, and then 1.
Oh. Are we going to get to a point where we're doing that many?
I don't think so. I think the most that we do is 8. Okay, so what's the next thing that I want to do on this? Yeah, U implies W. So when is that going to be true? Is all I'm hearing. What? Anytime U is false.
Anytime U is false, and anytime U is true and W is true.
Right. The only time it's false is when U is true and W is false. All right, what do I want to do next?
W.
It's not or,
Well,
it's and, right? Just remember it looks like that capital A. What has to be true for that statement to be true? Both W and X have to be true. So this is true, that's false, this is false, this is false, and then the same thing happens down here. This is true, false, false, and false. And then finally, U implies W, or W and X. So what has to be true for this to be true? Yeah, just one. Either U implies W or W and X. So on this first one, U implies W is true. I don't even have to look any further. Same for the second one. For the third one, neither one of them is true, so that's false. For the fourth one, neither one is true, that's false. For the fifth one, both are true, but I only needed one. I think the rest of them are true. Okay, any questions about that? Okay, again, that will not be on Thursday's quiz. Okay, but it will be on our test next week.